Welcome back to Mr. Wickland's Virtual Classroom, where today we're continuing to look at measurement. But what we're going to look at is, instead of looking at perimeter, we're now going to switch our focus to area. And area is what we're going to do is we're going to write it in square centimeters, and then we're going to look at the area of rectangles. So area is different from perimeter, because the perimeter, what we did is we measured the outside of a shape. But with area, what we're going to do is we look at the amount of space that's taken up by the shape. Okay, so we're no longer just measuring the outside, but what we're doing is we're looking at the inside. So where perimeter focuses on the outside, area looks at the inside and how much space is being taken up by the desk. Not just looking at the surface area of the desk, which is one-dimensional because it's just the top. What we're looking at is how much space is being taken up by the desk. So area is two-dimensional. It has a length and a width. And area is measured in square units. And today what we're going to be looking at is we're going to be looking at square centimeters. So when I take 1 centimeter and I multiply it by 1 centimeter, what I actually get is I get 1 centimeter squared, because I have 2 units of centimeters. And so I usually write that 1 times 1 is 1, and then because I have 2 centimeters, it becomes squared. Okay, which just basically what this says is 1 centimeter times 1 centimeter. That's all it is. Okay. What we're going to do is we're just going to look at simple areas. So like I said, perimeter, what we would do is we would focus on all of the outside edges, right? That's what we would focus on with perimeter. Well, with area, we actually focus on the inside. And so what the easiest way to figure out area is to actually just count the squares, because 1 square is 1 centimeter squared. Okay, so that's 1 centimeter squared, because that's 1 square. 2 centimeters squared, 3 centimeters squared, 4 centimeters squared, 5 centimeters squared. Again, we're looking at how much this shape takes up, how much space it takes up. Okay, we're not looking at the perimeter anymore, we're looking at the inside. So each square is 1 centimeter squared. So I have 1, 2, 3, 4, 5. So therefore I have 5 centimeters squared. Okay, what we'll do is we're going to take a look at another shape, and this time the lines aren't given to you. You actually have to draw those in. So using a ruler, which I should be using, and I can't seem to find mine right now. So, oh, there we go. So if I just draw the lines in, what you're soon going to notice is that you now have squares to work with. So when I connect the lines, I now have squares, just like I did in the first example. And I want to find out what the area is. Well, what did I tell you to do here? I said count the squares. 1, 2, 3, 4, 5. That was my area. It's pretty simple. Well, let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 squares, so therefore my area is 10 centimeters squared, because each one of these is 1 centimeter by 1 centimeter. Okay, so 1 centimeter squared. So therefore you have 10 centimeters squared. So that's simple area. Area is just figuring out how much room a shape takes. That's area. We focus on the inside. Perimeter, you focused on the outside. Area, you focus on the inside. Okay? So what we're going to do is we're going to look at an area of rectangles. Okay, so we've done with simple area, and area is quite simple to begin with. It's just the area. What's it take up? Area of a rectangle, it actually has a formula. And the formula is pretty simple. Length times width. Okay? If you can remember that formula, you will go places. Formula for rectangles is length times width. Okay, and what we're going to do is your book kind of focuses on the length times the width, and they get you to write some multiplication statements and things of that nature of using arrays, which you've done before. You know, you got this. What's our multiplication statement? And you would say, well, you got 2 rows, 3 in each row, and equals 6. Okay, what we basically did there is we said the length, which is 2, times the width, which is 3, equals 6. Okay, that's all it is. That's all there is to it. So let's look at our example here. Okay, and what we're going to do is we're going to take a look and we're going to write the equation out, and I'm going to walk it step by step through with you. Okay, so let's find out what our length is. Our length is 1, 2, 3, 4, 5, 6, 7. So this whole side right here, this whole thing is 7 centimeters. So our length, because area equals length times width. This is just a short formula. So if you only know length times width, bang, you can find area easily. This is where multiplication comes in handy. So knowing our times tables will come in handy for this as well. So what's our width? 1, 2, 3. So our width is 3 centimeters. So then if I know what my length times my width is, I don't need to know anything else. I don't need to count the rest of the squares. I don't need to do anything else because I know what my length times my width is. So my area equals 7 times 3, which is 21, and then my 2 centimeters squared. So if we counted all those boxes, we should get this number right here. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? So again, instead of counting all of the boxes, we now use a formula. We find out what the length is, we find out what the width is, and we use the formula. Let's do another problem together. One that you're going to see in your book. Most likely. It's going to look similar. I'm just going to change it up a little bit. And what we're going to do is we're going to focus on the area, and we're going to use our I can't speak all of a sudden. We're going to use our equation to solve what the area is for. Should put my lines a little differently, but that's okay. We're going to see each one of these as centimeters. Just go with it, please. So what we're going to do is we're going to put our lines in, okay, because this is what you're going to see. You're going to see this in your book. So you have to make the squares, just like you did for area. So you make the squares. Da, 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 da. No big deal, right? Use your ruler, make your squares. Okay. Now, find out what our length is. Find out what our width is. And then what we're going to do is we're going to plug it into the formula. So we know that area equals, now you can use a short form like I did up here. A stands for area equals L times W, length times width. So then A equals, so let's find our length. 1, 2, 3, 4, 5, 6. Length is 6 centimeters. What's my width? 1, 2, 3. 3 centimeters. So area equals length times width. My length is 6 centimeters times my width, which is 3 centimeters. So then my area equals 6 times 3, 18. Because I have 2 centimeters, I can't write centimeters. That's why we use centimeters squared, because I can't write 2 centimeters. Okay, so what we do is we do centimeters squared. Because you can't, it looks ridiculous if you write 18 centimeters. We can't do that. That's why we use squared centimeters. That's why we put that squared symbol in there. So my area is 18 centimeters squared. So guys, I have a feeling that you are going to have no problems with this. You're going to pick this up easily. And just remember that area is the amount of room that the shape takes up. Okay? The amount of room the shape takes up. It's different from perimeter, because perimeter, what we do is we focus on the outside edges. Area, we focus on the inside. How much room is the shape taking up? That's our math lesson for today. This is Mr. Wicklum signing off.